Hello, my friends. I can't believe what I'm about to tell you, but it's absolutely true. That's exactly how it happened. It's May 3rd, 2006. We have Armavia flight 967, which is going from Yerevan, that's in Armenia, to Sochi, that's in Russia. It's about an hour's flight from there. The plane is scheduled to take off at 2 a.m., 1:45 in the middle of the night. It's a time when the pilots are already extremely tired. One might wonder why, for a route like this, they have to schedule a flight in the middle of the night. It doesn't make any sense, but, well, that's how it is. On board this French-made Airbus A320, there are 113 people at the moment it takes off. The weather in the region is absolutely terrible. Just to give you an idea, to fly the approach into Sochi, you needed 2,500 meters of visibility. The actual visibility at the time they left was 2,000 meters, and the visibility forecasted by the meteorological services, the one that was on the TAF, was 1,500 meters. So the situation was getting worse. The ceiling wasn't high enough, which means the clouds were extremely low, below the minimum. A ceiling of 170 meters was required to be able to land. The clouds very often were below that value. So our pilot takes off, wind towards Sochi, located north of the flight, and then, along the way, he contacts the controller at their destination to get a final weather update. They knew it was bad. They were worried, and that's why they made that contact. He says the situation is completely socked in. He gives them the weather readings. He observes them in real time. He has a weather radar. He has some photoelectric cells outside that give him real-time information. He gives them the information, and with that, he decides to turn back. He realizes that, given what he's telling them, there's no point in going all the way to Sochi and then not being able to land. So they're practically in the middle of their flight, and that's when he decides to turn back. So they turn around and head back to Yerevan. The story could have ended here. They could have landed, gone to the hotel, and then try again in the morning. That's often a very good idea. Except that after about 15 minutes, they contact the controller again. And then they're going to try to put some pressure on him. They're going to say, we have very important officials on board the plane. In some parts of the world, that kind of argument works. They just want to worry him a little by saying, well, look, we have VIPs, so you better pay close attention to your weather report. In a way, if you look at the accident of the Polish president's plane, which crashed in the fog with almost zero visibility during an approach, also in Russia, it happened pretty much along those lines. We have officials who don't want to accept that the laws of physics apply to them. In this specific case, on Armavia 967, there were no officials on board. It was just an idea from the captain to try to add a little bit of pressure. In response, the controller tells him, well, listen, the visibility is 3,600 meters. I don't know where he got that from, maybe out of a hat, but suddenly the controller comes back to his senses. Since the controller comes around, well, they also decide to come back, so another U-turn, and they head back to Sochi. It was clearly a bad idea, regardless of everything else. Why? Because once the pilots made a U-turn and then made a second U-turn, the whole night was starting to turn into a mess. Let's imagine, just to give you an idea of the psychological pressure, let's imagine they arrive in Sochi, they can't land, and they have to go back to Yerevan again. You see what that would look like. That night, there would have been phone calls made to company officials saying, listen, the Airbus, it's yours, take a look at your radars, it's doing all sorts of crazy things. So the pilots are on the verge of starting to do something reckless. That's why now they're putting enormous operational pressure on themselves to land in Sochi. So they arrive in the area near the airport, they want to start their descent, and then something strange happens. When they start a managed descent, it means that the descent profile is controlled by the FMGC, managed by the system, by the onboard computer of the Airbus. Well, when they press it, what the Airbus will do is descend at 1,000 feet per minute. It will set 1,000 feet per minute, and it will start a very slow descent. The captain is starting to get a little irritated, and there will be more and more irritation in this cockpit, by the way. He's getting irritated with the Airbus. The cockpit had actually noticed the mistake. The mistake is that a waypoint was added to their route, which artificially increased the distance. And so indeed for the Airbus system, since we have a lot of distance to cover because of that point, obviously I'm going to descend very slowly. That's why he started doing that. The captain starts to get a bit frustrated with the Airbus systems, and then he ends up starting a faster descent, but the speed will increase. And in reality, throughout his entire approach, he will always be too high and too fast, which is problematic. Because planes need to lose energy as they descend, and they have to make sure they're in the right place at the right altitude at every point. So, if they arrive too high and too fast, it will throw them off more and more as they get closer to the airport. And that's exactly what will happen, by the way. Donc, so now, despite everything, despite all these setbacks, they still manage to get lined up with the approach path. There's an ILS approach. It's an approach that's always done from the sea towards the land. Departures from Sochi Airport always head toward the sea, while arrivals come in from the sea toward land. Why? Because behind the airport there's a lot of terrain, so it's not possible to operate toward the mountains. You can't take off toward that terrain or approach over it to land. So it's always towards the sea. So they get into the approach path, they manage to capture this ILS, start to descend, extend the flaps, and lower the landing gear. They're fully configured despite everything. So normally in the next few minutes they're going to land. They're receiving landing clearance from the controller, so everything is going well so far. And suddenly, the controller comes on the frequency and he doesn't want them to land anymore. He tells them the ceiling has dropped below 170 meters. Well, let me tell you something. There is a way of working in Russia that is completely different from the rest of the world. And to be honest, some of their practices might have a justification, even if we don't agree with them. They have a certain operational plausibility. So out of intellectual honesty, we can always defend them, show some of their advantages. But here, regarding the authority that the controller has, it just doesn't make any sense at all. It's really hard to find an argument for that. Actually, in Russia, the controller has a lot of power. Literally, sometimes it feels like the pilots are under his supervision, whereas in the rest of the world, he's there to facilitate air traffic, avoid conflicts, and that's it. But in Russia, it's different. So what's going to happen is the following. Normally, if we're making an approach, I don't know, in Lyon or Algiers or wherever, well, what happens is that the controller gives the weather, the clearance to land and so on. But after that, it's up to the pilots themselves, right? When we're doing an ILS approach, to descend along the ILS, isn't it? Until the decision height. Once the plane reaches the decision height, if the runway is in sight, it continues. If the runway isn't in sight, the pilot goes around. So in reality, once the plane is on an approach, the next important decision point is what we call the decision height. It's at this height that the pilot decides, do I have visibility? Do I see the runway or its lights? Do I continue or do I go around? In Russia, it's different. In Russia, the controllers are constantly checking the ceiling. So they have a device with photoelectric cells, as I was saying, in the tower. They monitor the ceiling in real time, and then every few seconds a new reading comes in. And if a reading comes in that's below the minimums, they require the pilots who are already on the approach path to do a go-around, which makes absolutely no sense at all, because the pilot is at the beginning of his approach. Well, he goes around. Then what? That means maybe 30 seconds later, we'll have a reading that's within the minimums. So it really makes absolutely no sense. You see? Secondly, the order the controller gave from that moment on, because he's going to tell them to go around, even if he doesn't use the words go around, is going to create a bit of confusion. He's going to ask them to climb to 600 meters and turn right. That's not what he's going to tell them, which in reality matches the published go-around procedure, but he won't say the words go around. The thing is, the order he gave them was illegal. Why? Because in Russia, well, there are Russian laws that apply, but there are also the rules of ICAO. So, for local flights, that means flights by Russian airlines coming from Russian destinations, let's say Moscow, Sochi. In that case, it's the Russian rules that apply from the Russian Federation. For international flights, the controllers can't apply Russian rules, but they apply the rules of ICAO. So, in reality, since it was a flight coming from Armenia, it was an international flight, it wasn't a Russian airline, the controller wasn't allowed to give that order. And actually, in reality, the pilot could have refused it. The pilot could have said, we are operating according to ICAO rules. I will continue until the decision height. If I see the runway, I land, period. If you're not happy, make a report later. And the pilot would have been right. But in this specific case, when the pilot received that order from the controller, he decided to comply. The problem was he had a little issue, and I'll tell you about it. He's only at the beginning of his approach. The altitude he's being asked to reach in case of a go-around, 600 meters, is relatively close. It's quite near. What is a go-around on an Airbus? It's the same as on a Boeing. It's taking the throttle lever and putting it on what's called toga. That means putting it to the maximum, really, pushing it all the way. The engines accelerate, and under these conditions, what happens is that the moment the throttle reaches toga, the aircraft systems, the navigation, all of that, now switch to go-around mode. Problem? There's a problem. Here's what it is. The thing is, it's very annoying to do a go-around when the plane's current altitude and the altitude it needs to reach for the go-around are very close together. Why? Because the engines are very powerful, and when they reach maximum thrust, the plane gets a very nice rate of climb and can quickly break through that ceiling and go above it. All right, so that's a little bit what's annoying about it. So in this specific case, Airbus recommends in these situations to still go to toga quickly. You know, some people call it toga tap. So they go to toga, so maximum thrust, just enough time to mentally count to 2, then bam, reduce the thrust afterwards. But the system has already registered that we're in a go-around logic. That's not what the pilot is going to do. The pilot is going to do this. The pilot, first, he's going to take, there's a button. There's a button that allows you to select the vertical speed. That button, normally, nothing is displayed for vertical speed. Why? Because the plane is in approach mode. So, the vertical speed is calculated automatically, and it's dynamic. It varies depending on the speed and all that. So there aren't any set vertical speeds. But this button, if you press it, the plane stops descending. The plane will level off. That means it will stop descending. So, when he presses it, several things will happen. First, the approach mode is cancelled, so the plane will stop descending. And regarding the axis, which direction will it go now? Well, it switches to heading mode. That means Airbus has this logic. If the approach is cancelled in this way, the altitude will be held, and then the direction, it won't be a route or a runway centerline or anything at all. It will simply be a heading. All right, so he presses it. There you go. Now he decides to climb. The captain decides to climb, so he goes to the altitude window. He will select an altitude higher than the go-around altitude. So instead of 600 meters, he will select a much higher altitude. He will select 2,100 meters. We work in meters, we're in Russia. And actually, to reach this altitude, what will he do? He will press another button called Open Climb. It's the climb, one of the steepest climbs on an Airbus. An even steeper option exists with the expedite button, but it's not on all Airbus planes. But just so you know, he did something completely unimaginable. He cancels an approach, and while he has the flaps fully extended for landing, he has the landing gear down, and well, he's going to select Open Climb. That's not something the Boeing engineers thought about, because you don't normally go from landing straight to Open Climb. What does exist is that from landing, potentially there's a go-around. But Open Climb is a little bit surprising. What's going to happen? Several things are going to happen very quickly in very rapid succession, and that's what's going to end up completely confusing the captain. This is what's going to happen. The engines are accelerating. The plane pitches up very abruptly to 21 degrees. There are 1.3 Gs recorded in the case of this open climb. And why? Because normally the Airbus, when open climb is pressed, it adds 0.15 G. That means it goes up to a maximum of 1.15 G. That means it will make a pitch up that is fairly sharp, but still relatively reasonable. Nevertheless, because of Airbus's programming, logically, if open climb is pressed within a 30-second window after pressing level off, the first button, this time the pitch up is much more aggressive. This time the autopilot is allowed to go up to 1.3 G. Alright, so it's much more abrupt this time. So when he presses open climb, the engines accelerate. The plane pitches up to 21 degrees. So a very nice pitch up. Because internally, in these algorithms, it's still algorithmic. It aims for 8,000 feet per minute. In reality, it will never reach 8,000 feet per minute. But it's a value, if you will, it's a value that's in the algorithm. It means we do the following. We're going to act as if we want to reach a virtual value of 8,000 feet per minute. So that's what causes this aggressive pitch up and the engines to accelerate abruptly. And then what do we do next? After that, we'll reach whatever we can before 8,000. So maybe 3,500, maybe 4,000, maybe 2,800. It doesn't matter. It depends on the conditions of the day. And we monitor the speed. If the speed starts to drop, once it goes below a certain value, what we'll do is we'll start to shallow the flight path. We'll gradually level out the trajectory, so we'll never actually reach 8,000. But it's a virtual target that's in the system's algorithm. That's why the pitch up is so aggressive. So something else is going to happen. What's going to happen is that when it does that, the plane pitches up, the engines accelerate, but the speed will drop a little. At that moment, an alarm will go off in the cockpit. Speed, speed, speed. It's a man's voice that will start shouting. Speed, speed. That means actually there's low energy. The Airbus is in a low energy phase. So the speed alarm can sometimes go off, for example, when the plane is in landing configuration with the flaps out and the landing gear down. The engines they're not giving enough power, the speed has dropped and the angle of attack is high. And what does that mean, basically? It means that you could say if we're talking in terms of general aviation, we're simply behind the power curve. That means the angle of attack is too high, and there's no way, once you hear that alarm, there's no way to increase, to get a positive climb on the Airbus just by pulling back on the side stick. There's no way. That means if the side stick is already almost fully pulled back at this point, and if the pilot pulls back even more, the plane won't, and it might pitch up a little more, but it will keep descending. It can't climb again unless more thrust is added. Tests were later done in the simulator by Airbus and by the BEA investigators, because there will be an investigation. You can imagine where this is going. And they will find that systematically when you're in landing configuration and you do what this pilot did, that means you go straight from the landing configuration. In open climb, there's a transitional phase during which the speed alarm will go off. Yes, there is this transitional phase. Nevertheless, the plane doesn't crash, right? There's no risk at all that the plane will crash or anything like that. It's not going to crash, it's not going to stall, nothing like that. It's just going to do something that's quite surprising. And since the pilot went outside the normal usual range, he encountered a reaction from the Airbus that completely surprised him. So, the plane pitched up sharply and he was surprised, right? At that moment, the aircraft was actually already starting to give nose-down commands. That means, yes, it had pitched up to 21 degrees, but the onboard computer was already sending nose-down commands through the system. That means to reduce that pitch-up. It was in the process of reducing that pitch-up, except the pilot didn't wait for that moment. He didn't realize it was already happening. He lost confidence. That's it, he acted out of mistrust. He lost confidence, and by losing confidence, he disconnected the autopilot. So, he disconnects the autopilot, and what does he do? He gives a nose-down command. Honestly, at that point, he's going to dive. The plane was banked to the right to avoid the mountains, and so it was also aligned with the runway center line. So he pulled up and initiated a climb on the axis, and also the turn. So what is he going to do? He's going to tighten the turn while starting to push the side stick forward. At the same time, he was making some strange, meaningless movements on the rudder pedals. So the rudder pedals are basically only used in case of an engine failure or strong winds during approach or something like that. But here, there was no reason to use the rudder pedals, but he's going to use them. So what he's going to do is start to push the nose of the plane down. When you push the nose of the plane down, the speed will increase. So the aircraft is in an overspeed condition. He retracts the flaps, and after a while, even the flaps retract automatically because there's a protection system on Airbus to prevent damage. At a certain speed, the flaps retract automatically, but the landing gear remains extended since he doesn't think to retract it. But he starts giving more and more nose-down commands, even though he's just above the water, literally right above the Black Sea. At that moment, the co-pilot is going to get involved. He's going to get involved at the moment, actually, when the GPWS starts to sound the alarm. That means at the moment when the GPWS realizes that the plane is heading toward the water and starts yelling, "Pull up, pull up, pull up," they actually had the opportunity to pull up and recover the aircraft, but unfortunately, that wasn't done. Well, the co-pilot comes in with his hand like this on the side stick, and he does this. That means the plane is pitching up to the right, which actually wasn't even the most important thing, because on an Airbus, it will never flip over, since there's a limit. There comes a point where it won't go any further, but it's as if the co-pilot first wanted to correct it, to bring the wings back to level. That was his first concern when he should have been more focused on pitching up. So, what did he do? He moved his arm, and in a panic, he made a semicircular motion. He made a circle like this to grab the side stick, right? To grab the side stick. I'll show you something. He grabs the side stick like this to bring the plane to the left. So his idea is to bring it to the left, but he actually does this. I don't know if you can see it. All right, he does this. And actually, he's going to go to the left, he's going to make a move to the left, and at the same time, he's going to make a move forward to pitch down. So he's going to reinforce in a way the dive that had been initiated by the captain. So he's going to add to it, because on the Airbus it's the algebraic sum of both inputs that's added together. So we're going to add to it. If the one on the left is pushing the nose down and the other one is also pushing the nose down, well, the nose goes down even more. So that's that. On the Airbus, there's no protection to stop you from hitting the ground. There are many protections, but if the pilot chooses to descend, the Airbus can't stop him from hitting the ground. Right. Now, at this point, our captain realizes that he's heading toward the ground. He realizes that something is wrong. It's as if he's waking up a bit from his stupor and his panic. He grabs his side stick and pulls it for a response. Except that since the co-pilot's side stick is pushed forward, okay, what happens? The two will cancel each other out. Remember, it's always the algebraic sum. Earlier, when both were pushed, the plane nosedived. But now, what we have is one side stick pushed forward and another one pulled all the way back, so the algebraic sum is 0, which means the plane doesn't react. Normally, under normal circumstances, when there's a situation like this, when both pilots are acting on their side sticks at the same time, there's a voice. There's a man's voice that says dual input, dual input. That means both are doing something. This voice won't sound in the cockpit of this Airbus. And why? There's another reason. We're constantly switching from one logic to another. We're right in the middle of algorithms, It's, as I often tell you, if it had been a 737, we'd be talking about oil, fuel, cables, pulleys, and linkages. When it comes to Airbus, we're always dealing with logic, It's always about logic, algorithms, and so on. There's a reason. It's because when multiple alarms could be triggered, if a situation sets off several alarms, like in this case, 2 alarms should have gone off. It's the GPWS, because we're approaching the ground. The GPWS should go off. It should say pull up and so on. Now, we have a second alarm that should go off. It's the dual input alarm. In this case, the system is programmed to assign priorities, and it's the highest priority alarm that will override the lower priority alarm. So yes, everyone knows that this is all simulated. Well, you see, if I touch it, you do the opposite, or you touch it, you do the same thing. That's dual input. It's nice, it's great. Yes, but that's not always the case. Dual input isn't always heard. If there's an alarm with higher priority than dual input, it won't be heard. And GPWS has higher priority. So put yourself in the captain's shoes. He was sure he was going to land. He didn't have a plan B. The weather is terrible. He got upset with the plane. He got upset with the controller. Nothing is happening. Now he has the GPWS blaring, and put yourself in his shoes. When he pulls the side stick, nothing happens. He doesn't hear the dual input warning, but nothing happens. So for him, in his mind, he says this is witchcraft. He feels like the referee isn't answering or responding to him. He pulls hard on the side stick while the referee keeps pitching down. Yes. Also remember that a few seconds earlier, a minute earlier, he had already lost confidence when the plane pitched up too abruptly and he got a speed alarm. For him, it feels like this plane is doing whatever it wants tonight. And now he completely loses confidence. The worst that can happen is he pulls and nothing happens. The co-pilot realizes his mistake 3 seconds before impact. He also pulls on the side stick and the plane slowly pitches up. Bam, impact with the water. We calculated that up to 5 seconds before impact, the plane was recoverable. Up to 5 seconds before impact, it was possible to give the side sticks a sharp pull and the plane would have pitched up. It would have climbed away. It would have been close, it would have barely made it, but it would have made it. Except that's not what happened. Bam. 113 dead on the spot. Everyone was killed. Controller. Meanwhile, in the seconds before impact, the black box records the controller, who says in his monotone voice, "You can come back and land." The ceiling has just lifted. I'm going to say it's too late. There, the plane is crashing. It's not landing. So, when the plane doesn't respond anymore, the rescue teams go out. There you go. At 4 a.m. they will find indeed a slick of oil or gasoline, floating objects, and so on. At the same time, they'll wake up the Armenian president to tell him, well, that's it. Armavia is done for. And so this investigation will begin with the Russians, the Armenians, the BEA, all of them. Then after that, there were a lot of rumors and so on. But aviation in this country is very political, you know. Because generally, when you look at the investors in the airlines, they're politicians, military people, well-connected people, financiers, all of them. So it creates a kind of murky backdrop. Armavia went bankrupt in 2013. They had lost, actually the day after this crash, they had lost another plane, an Airbus that caught fire in Brussels, in a hangar. So it was an airline that was doomed. So it kept operating, just barely. It closed its doors in 2013. And today, Armenian aviation is banned in the European Union. They are not allowed to come to Europe. A lot of things they're trying to solve their problems. Many have been resolved, but not all of them actually. Many problems still remain unresolved. And we say to ourselves, we can say that, for example, in the case of the pilot, the captain who panicked, we can say that, for example, on an Airbus, given the protections in place, if you really panic, you freak out, you don't know what to do, you're completely disoriented, you're under emotional stress. Emotional, that's the word used in the report. They were under enormous emotional stress, panic, worry, frustration, fear, all of that. If we're in that situation and we feel like our neurons are starting to short circuit on an Airbus, we can say that maybe we're leaning more towards safety. If you pull the side stick all the way back, it won't stall. You can pull as hard as you want, push the throttles to full power, and even if you forget, it will do it automatically. So, what the system will do is it will moderate our input, right? It will pitch the plane up, but it won't take it all the way to a stall, so it won't stall. The throttles, either we push them to full power ourselves, well then the plane will climb, or if we forget to do it, when it gets close to the stall threshold, it will do it by itself and the plane won't crash. Just pull the stick all the way back, push the throttles forward, but you don't even have to push, it'll do it by itself, right? The throttles will go to full power. And then we wait for things to calm down, okay? We can say that, right? Can't we? When we look at Armavia. Because the pilot, he pushed. Except the problem is the reasoning I'm giving you. We're talking about Air France 447. All right, in the panic, I don't know what's happening. It's night, the weather is bad, turbulence, the plane is doing weird things. I don't trust my instruments. I don't trust anything at all. I pull on the stick, I push the throttle all the way, and the plane, it saves me. You see what I mean? There's no miracle solution, unfortunately. There's no miracle solution. Because it was on Air France, that's what he did. He kept the plane completely nose up. On the Armavia flight, well, he did the opposite. He nosedived, he ended up in the water. Thank you, my friends, for watching this video up to this point. It was May 3rd, 2006, near Sochi. 113 dead. Most of the bodies were recovered and everything, but most of the parts and all that are still at the bottom of the deep Black Sea, 500 meters from shore and 500 meters deep. Thank you, and I'll see you in the next video.